All right, hello everybody. So 18.3, solving equations by using quadratic methods. This is everything that we've worked up to, okay? There is really no rhyme or reason to this. What we need to do is just solve problems. So I'm going to just go ahead and do a bunch of examples for us, and that's going to be it for this lecture. So example 1. Let me just write this. Solve. Like everything we're going to be doing today is solving. So first example, x minus the square root of x plus 1 minus 5 equals 0. So hopefully here you can see we have a radical term, which means we need to isolate this. So let me rewrite the problem. So first thing I'm going to do is I'm going to add the square root of x plus 1 to both sides. Okay? Now, the reason why I do that is I see that there's a negative sign in front of the square root symbol. So I just want to make it positive, that's all. And by doing that, notice I've isolated both sides, or isolated the radical. So now what I'm going to do is I will raise both sides by the index of the radical. All right. So the right-hand side, that's really simple. I get x plus 1. Now remember, on the left-hand side, you have to take x minus 5 times x minus 5. And that's going to give me x squared minus 5x minus 5x plus 25, or x squared minus 10x plus 25. So that all goes on the right, or on the left-hand side. So x squared minus 10x plus 25. Okay? So now I see the quadratic term. I'm very excited because now we have 4 methods. We could factor, we could complete the square, we can use the quadratic formula, we can also use the square root property. Remember, I told you, if I don't specifically tell you how to do the problem, pick the method you like the most. So I'm going to use the quadratic formula. But in order for me to use the quadratic formula, all right, let me put the Q formula here. We got to set this equal to 0. So what I need to do is subtract x from both sides. First, that's going to give me negative 11x plus 25 equals 1. And then subtract 1 from both sides. And that gives me x squared minus 11x. What is that? Minus, how about plus 24 equals 0. Okay? Now, I got to be honest with you. You always want to check this first. I know I said I'm going to use the quadratic formula, but now that I've seen what it actually turned out to be, I'm going to factor. So I pulled a fast one on you, and I'm sorry for that, okay? But as soon as I see the x squared term, I'm already thinking quadratic formula because it's easy to do. Quadratic formula because it's easy to do. It just so happens that this one actually gets, we can factor this. So I write an x and an x, a minus and a minus. How about 8 and 3? Set each one of these equal to 0. So I'm going to add 8 to both sides for the first solution. That gives me x equals 8. For the second, I'll add 3 to both sides. And that gives me x equals 3. Now, you have to notice I didn't circle anything yet. And that's because since I have a radical inside this problem, all right, since we had a radical, let me go all the way back up to it right here. I need to check my solutions, okay? I got to check my solutions. So what was the original problem again? It was x minus the square root of x plus 1 minus 5, and that should equal 0. So check. X equals 8. Well, that's going to give me 8 minus the square root of 8 plus 1 minus 5. That's going to give me 8 minus 3, because remember, 8 plus 1 is 9. Square root of 9 is 3, so 8 minus 3 minus 5. And when you do this, you get 8 minus 3, which is 5, and 5 minus 5 is 0. So that is a solution, so I circle it. All right? Now let's check x equals 3. So that's going to give me 3 minus the square root of 3 plus 1 minus 5, and that should equal 0, okay? It should equal 0. Let's see. We get 3 minus, well, 3 plus 1 is 4. Square root of 4 is 2 minus 5. 3 minus 2 is 1 minus 5. And I know 1 minus 5 does not equal 0. So I put an X, write the word extraneous or extra, okay, and call it a day. So the only solution is x equals 8. Another way to write that is like that, okay? Next problem. 5x over x plus 1 minus x plus 4 over x equals 3 times x over, or 3 over x times x plus 1. All right. Uh-oh. The dreaded fraction problem, but we know that if we don't like fractions, we got to get rid of them. So I look at the denominators. X plus 1, which is right here, x right there, and then x times x plus 1. And I need to find that LCD because I'm going to multiply everything by that to eliminate all denominators. And here's the beautiful part. Your denominator, your LCD, was staring you in the face right here. It's x times x plus 1. Remember, if you have no idea how to find a common denominator, let's say the problem is complex, just multiply them. You'll always get one. All right? So what I'm going to do here is I'm going to multiply everything by x times x plus 1. So let me write this out. So we get x times x plus 1 times 5x over x plus 1 minus x times x plus 1 times x plus 4 over x equals x times x plus 1 times 3 over x times x plus 1. Okay? Now, let's take it easy. We'll go left to right. We know the x plus 1 and the x plus 1 reduce to 1, so what's left over? X times 5x. Okay? Minus. Now, this x and this x cancel each other out. They turn into a 1. So what's left over? X plus 1 times x plus 4. And then on the right-hand side of the equation, this x and this x will turn into a 1. They reduce. The x plus 1 and the x plus 1, that reduces. So you are literally left over with just 3, which is great. So now let's move from left to right, simplifying. So we get x times 5x, which is 5x squared, minus, well, it looks like we need to distribute. Okay? So I'll come over here to my little piece of scratch paper over to the right. I'll put the x plus 1 times the x plus 4. So that's going to give me x squared plus 4x plus x plus 4, or x squared plus 5x plus 4. Now, you have to be very careful because do you see this minus sign right here? You have to put parenthesis x squared plus 5x plus 4. All right? Equals 3. So, once again, we're just going to keep simplifying. 5x squared minus x squared minus 5x minus 4, because what I did is I distributed the negative sign to each one of those terms, equals 3. All right? So that's going to give me 4x squared, because 5x squared minus x squared is 4x squared, minus 5x minus 4 equals 3. I'm going to set this equal to 0. So I subtract 3 from both sides. That gives me 4x squared minus 5x minus 7 equals 0. And I'm not even going to try to factor this. I'm going to go right into my quadratic formula. Like, I'm going right into that. So A equals 4, B equals negative 5, C equals negative 7. And let's just, you know what? Let's just do it, okay? X equals negative parenthesis, negative 5, plus or minus the square root of negative 5 squared minus 4 times negative 7 all over 2 times 4, okay? So that's going to give me x equals 5 plus or minus. Now, I'm just going to get out my calculator real fast. because we're going to have negative 5 squared, which is 25, minus negative 4 times 4 times negative 7. Well, that's going to be plus 112 all over 8. Okay? That's going to give me x equals 5 plus or minus the square root. 25 plus 12 is 137. Now, 137, actually, that's prime, if you didn't know that. And you probably didn't know that. You know, I only know that because I've been doing this for a long time. But 137 is prime, so there's my answer. If I wanted to, I could separate that. X equals 5 plus the square root of 137 over 8, or x equals 5 minus the square root of 137 all over 8. Okay? All right, let's do the next problem. Like I said, we're just going to just do these problems. That's it. Okay? So, example, p to the 4th minus 7p squared minus 144 equals 0. Okay? Now, I'm going to teach you something here. Okay? We know what this is what we're really looking for. Ax squared plus bx plus c equals 0. I mean, that's what we've been studying, okay? Now, if you look at our problem, it's already p to the 4th minus 7p squared minus 144. In other words, it doesn't quite look like what we've been studying off to the right. Ooh, what happened there? It doesn't quite look like what we've been studying off to the right, okay? But it is. All right, let me show you. I'm going to teach you a trick here. All right, first, and it's not a trick. I don't want to say it's a trick. I hate saying that. This is not a trick. This is what it is. First, all right, if you have, and what I'm going to do is I'm going to write this in very general terms here. Ax to the 4th plus bx squared plus c equals 0. Then you're going to let u equal x squared. So you can rewrite ax to the 4th plus bx squared plus c equals 0 as, and you ready for this? A u squared plus bu plus c equals 0. Okay? All right, now, you may be asking yourself, well, where is this coming from? Okay? Well, if you look at p to the 4th minus 7p squared minus 144 equals 0, okay? What I could really do here is this p to the 4th, I could rewrite that as p squared minus 7p minus 144 equals 0. All right? All right? And by doing that, hopefully you can see that a power raised to another power, you multiply the power. So 2 times 2 is 4. Well, to kind of save us some work, if I could recognize that I have the ax to the 4th plus bx squared plus c, okay, what I can do is I'm going to let p squared equal u. So wherever I see, and this is my rewrite, wherever I see the p squared, I'm going to change it with the letter u. So I get u squared minus 7u minus 144 equals 0. Okay? So hopefully you see that. All right? Like I said, this is not a trick. It's just once you've done this enough, you start to see certain things happening. Okay? So I'm going to rewrite the original problem. P to the 4th minus 3. Oh, sorry. Wrong problem. P to the 4th minus 7p squared minus 144 equals 0. Okay? And what I'm going to do is I'm going to rewrite it with u equal to p squared. And it's going to turn into u squared minus 7u minus 144 equals 0. Okay? Now, I'm going to go ahead and use my quadratic formula to solve. All right? So let's see what happens. So A equals 1, B equals -7, C equals -144. So that's going to give me now, watch what I write here. This is going to be very important. I'm going to write U equals, because remember, with the quadratic formula, you use X equals. Well, since my variable is now U, I'm going to use U equals. So U equals -7 plus or minus the square root of -7 squared minus 4 times 1 times -144 all over 2 times 1. Okay? So that's going to give me +7 plus or minus. All right, we'll take this one step at a time. 49. And then -4 times 1 times -144 is positive 576. Okay? All over 2. All right? So like I said, we just take this one step at a time. No need to rush. Okay? So this is going to give me U equals 7 plus or minus the square root. Well, 576 plus 49 is 625 all over 2. All right? Okay? And that's going to give me U equals, okay, like I said, just bear with me, 7 plus or minus. Now, what's really nice is if you took out your calculator and you hit the square root of 625, you get 25 all over 2. All right? Now we separate. U equals 7 plus 25 over 2, or U equals 7 minus 25 all over 2. Okay? We're almost home free. We're almost there. Okay? So that's going to give me 7 plus 25, which is 32, divided by 2, or, U equals 16. Or U equals, 7 minus 25 divided by 2. 7 minus 25 is -18. And -18 divided by 2 is -9. Okay? So like I said, we're almost free. We're almost free. U equals 16. U equals -9. Okay? Now, let me scroll back up. And let me highlight what I'm talking about. Oh, that's the wrong thing. That's not a highlighter. That's a marker. Right here, we made this substitution. We said U equals P squared. Okay? So, what we need to do, and I'm going to write this in red, what we need to do is go all the way back down to our problem. All right? We need to go all the way back down here. And we need to, and I'm going to write it nice and large, replace U with P squared. All right, let me write that nicer. Rewrite U with P squared, because we let U equals P squared at the start of the problem. All right? So I get P squared equals 16, and P squared equals -9. And hopefully you can see how easy this is. I'm going to take the square root of both sides. P equals plus or minus 4. And then I'm going to take the square root of both sides for the other problem, or the other side. And P equals plus or minus 3i. And there are my solutions right there. Okay? All right? So we got one more example to do. All right? This one is going to look like the most difficult, but it's not, because I'm going to show you what we do. So the last example here, x to the 2/3 power minus 5x to the 1/3 power plus 6 equals 0. Okay? Now I know you're looking at the fractions and you're like, oh, I hate them. And like I said, I agree with you. I don't like them either. But what I want to do is I'm going to rewrite this. I'm going to show you what's happening here, all right? You have to recall, just like in the previous problem, all right? A power raised to a power means you multiply the powers together, all right? So watch what I do here, all right? Watch this. Let me write this out first, and then I'm going to show you what I did, okay? I'm just going to write it out real fast. There we go. That looks better. All right. Actually, we'll just erase it, put that. Okay. Perfect. So here you could kind of see that we have x to the 1/3, right? But that is being squared. In other words, this has that shape, or it has the form of ax squared minus or plus bx plus c, okay? It has that. So what I'm going to do here is exactly what I did in the previous problem. I'm going to let u equal x to the 1/3. And by letting u equal x to the 1/3, look what I get. I get u squared minus 5u plus 6 equals 0. In other words, wherever I see that x to the 1/3 power, I'm going to replace it with a u, okay? And let's block that in because we're going to have to make our substitution like we did in the previous problem at the very end. So let's factor. I know this can be factored. So I get a u and a u, a minus and a minus. How about a 2 and a 3? So this is going to give me u minus 2 equals 0 and u minus 3 equals 0. So I add 2 to both sides. That gives me u equals 2. I add 3 to both sides. That gives me u equals 3, okay? But now we must substitute, just like we did in the previous problem, u equals x to the 1/3, all right? So I'm going to rewrite as x to the 1/3 equals 2, or x to the 1/3 equals 3. Okay? All right. Now to solve, I'm going to raise both sides to the 3rd power, like we learned previously. We know a power raised to a power means you multiply the powers. So on the left-hand side, I get x, and on the right-hand side, I get 8. Okay? Now for the other example here, or for the other part, I'm going to do the same thing. X to the 1/3, I'm going to raise both sides to the 3rd. So on the left-hand side, that gives me x, and on the right-hand side, that gives me 27. Okay? So the last two problems that we did are the hardest ones because the quadratic part is hidden. All right? You just got to be aware of it. All right? You will have examples like this in your homework that you're going to have to do, but they are not difficult. They are like just straight up. You will know that you have to do it, okay? So I hope that helps, and I will see you in the next video. Bye-bye.